Another point about chaos, which I want to make in this context also, is we've mentioned this a bunch of times. The variability in a chaotic system, you see it going up and down a lot. But the variability in this system, in a chaotic system, is internal, or it's internally generated. Whereas, and here is our big contrast, what is the difference between chaos and noise, randomness? The answer is that in chaos, the variability is internal. It's generated internally to the system. In randomness, or what's called noise, the variability is external. It's imposed on the system. And as I was saying, the default assumption that everybody wants to make, and which is wrong, is variable output must be the result of randomness or noise. There's a very cute example of this that I want to share with you. I'm sure you've been at dinner at a nice restaurant with a little candle flame here. And I'm sure you've noticed the flame darting back and forth. Flames do that. So you ask yourself, what is the cause of the movement of the flame? Perfectly straightforward question. So I've asked this question at about 100 dinners, and 100% of the time, I get the same answer, which is probably your answer. Oh, the flame is darting around because of air currents in the room. The waiter goes by, I'm talking, you're talking. There's a lot of random external input, and that makes the flame dance around. So notice that that is an example of an external cause of the variability. The flame, according to this view, the flame should be stationary, but it's being blown around by outside forces, and that's producing the variability. Now, it's interesting, psychiatrists talk about the notion of an external locus of control. And it's unhealthy. But we all do it. We all have a tendency to do this. We see our lives as being controlled by external forces. How you doing today? Oh, my boss wants this report. He wants it by 4 o'clock, and it's just such a drag. And oh, my boyfriend, my girlfriend, my car needs fixing. I have to do a laundry. We tend to see things as if we are being blown around by outside forces. Not as healthy as what they call an internal locus of control, which is I am the source of the variability. I'm making this decision, I'm making that decision. The source of the variability is inside me, not that I'm being blown around by outside forces. This is regarded as a much healthier state. And if you look at the candle flame, the external explanation, as we said, is blown around by outside forces. And then some people had a very clever idea. Let's do this experiment in a very tall chimney with air bled in very carefully at the top so that there's no breeze at all. What happens to the candle flame? Answer, it darts around. So the cause of the candle flame dancing is not external. The waiter goes by and I'm talking and you're talking. The cause is much, much deeper. And I recommend that you look up the work of a woman named Kay Robbins, who is at Texas Austin, and studies what she calls flame dynamics. Only she's talking about real flames. And she studies flames under highly controlled conditions, and she finds absolutely clear mathematical patterns in the dartings of the candle, or the dartings of the flame. What's really driving this is, let's think about the flame, and let's think about the flame as having a center line. And our default assumption was the flame just stays on this center line in equilibrium. But that equilibrium is unstable. It has to be unstable. And it's unstable because the flame exhausts oxygen in a little neighborhood. And because it has exhausted oxygen in that little neighborhood, if it stayed in that neighborhood, it would die for lack of oxygen. So the flame darts up any oxygen gradient it can find, and there has to be an oxygen gradient because it just created an oxygen gradient by using up the oxygen in this little region here. So now it moves up a gradient of oxygen to fresh oxygen, and then it exhausts the oxygen there, and it must move again up an oxygen gradient. So the darting of the flame is internally generated by the fact that this is an unstable equilibrium point, and the need of the flame to find fresh oxygen is the cause of the darting of the flame. In other words, there's an internal locus of causality of the flame darting around.